Hello everyone, this is a presentation of our collaborative paper, Backtranslation Feedback Improves User Confidence and MT, Not Quality. Machine translation usage can be roughly divided into inbound and outbound translation. In inbound translation, we are the recipients of a message in a foreign language, and it is our responsibility to understand it correctly. Prototypically, it is reading a website in a foreign language. In the first row, we are perhaps reading a German email, and of course it is up to us to decode the correct meaning. Here we are assuming that German is a foreign language. For our personal use, it may be enough to use publicly available MT to get the gist of the message. In outbound translation, the direction of a foreign message is from us to someone else, and it is our responsibility to ensure that the message is grammatically and content-wise correct. An example here is communication by email or filling in foreign language forms. However, a reasonable person would not believe 100% of what comes out of publicly available MT system. They would not put it in an email and would not send it. For both cases, inbound and especially outbound translation, some feedback is needed. This feedback should tell the users if the translation is correct and if there may be errors. The goal is also to increase the user's confidence in machine translation. We focus on the following issue. A user wants to translate into a language they do not understand, which is a specific case of outbound translation. For that, they receive cues about translation quality, and they may continue working with the system interactively. There are two goals that we have in mind: increasing the translation quality as well as the user's confidence in the output. These are obviously not orthogonal, but also not the same. We therefore designed a system and an experiment, which we will discuss on the next slides. In this experiment, we control the feedback modules that are available to the users in order to determine the effect of each. We also control the specific MT system used to see how MT performance affects the process. We denote the setting of the stimulus and the specific subset of cue modules as a scene. Now we will discuss what interactions happen during one of such scenes. We start with the user who sees a stimulus in English. Specifically, the stimulus is a graph of a website containing a pre-filled form which the participants are asked to translate. The user then produces the source text, which has the same intention as the query in the stimulus. They may choose to simply copy it, or if they have some experience with MT, they simplify it. The source text is translated from English to Czech or Estonian, and the translation is shown. At the same time, the user is given a feedback, cues about the quality of the translation. Unlike the translation, the cues are in English, so the user understands them. In particular, the modules producing cues are a backward translation system, paraphrase, and word-level quality estimation projected through word alignment to the source text. The user perceives the feedback and possibly some hints from the translation itself, such as correct spelling of named entities. Then they decide if the source text requires another round of rephrasing. If not, the user may submit the final source text and its translation. They are also asked to report their confidence about the quality of the translation. When we look at the screenshot of Takopiat, we can focus on individual components of the experiment in more detail. The stimulus on the left is one of many collected by another group of annotators. They were instructed to first look for web forms on English pages that contain a text field for open queries, and then create a query that should be appropriate in the context of the web page. Some websites were originally in text. In the context of our terminology, the translation of the website into English was inbound translation, and now the users are producing their own text in outbound translation. The query highlighted in green rectangle is what participants of the experiment are asked to translate. The progression is as follows. The stimulus, "I would like to have a room with direct garden access," is shown to the user. They then rephrase the stimulus query and have it translated. The rephrased version is, "I'd like to request a room with access to the garden." It bears roughly the same meaning. The input gets translated into Czech. All the MT models are transformer-based. The best one, Czech teacher, is the current state of the art. From this, a student model was distilled and optimized on CPU performance. In comparison to its teacher, the qualitative performance is worse, but with much higher speed. For brevity, the other two MT systems are described in full in the paper. For each scene, the used MT system is selected randomly. Finally, the cues show the possible paraphrases, the translation back to English, and the word-level quality estimation projected to the source. The backtranslation is just the same MT, but in the opposite direction. The word-level quality estimation leverages glassbox features from the MT system itself. Unlike sentence-level models, performance of word-level models is in general suboptimal, which is confirmed also in our case. And lastly, the paraphrasing is done by simply translating from English to 41 different languages and then back to English. Every user saw each stimulus exactly once, but with different combinations of cues provided by these modules. For instance, whereas one user saw a stimulus with all cues, another two users could see the same stimulus with random subset of cues or with no cues at all. This allowed us to quantify the effect of each module. In the same manner, the user may then further interact with the outbound translation system, and once they are satisfied, they submit the final source text and its translation together with the confidence about the output. This is 4 in the presented example, and it means that they were mostly satisfied with the result and had confidence that it's adequate and generally correct. For clarity, we show the interface again. On the left side is the stimulus, and on the right side the MT input and the cue modules. We use around 50 participants and 70 Web4 snippets from the e-commerce domain as stimuli. This table shows rudimentary statistics of the collected data. The distribution of collected samples over different configurations is more or less balanced. Check Student is a CPU-optimized student system, which makes it much faster to respond. This is reflected in shorter average time spent per scene, yet performing more than twice as many actions. We asked the annotators to rate source texts and their translations using 5 different criteria. For simplicity, we show here only the overall quality of translation. Please see the paper for the rest of the measures. This graph shows how the presence of different key modules and entities influence the self-reported confidence and the overall translation quality. First interesting thing we notice is that the student model, despite having worse objective quality, is on par or even slightly outperforms its teacher when it comes to user confidence. We hypothesize that this is caused by the high speed of the student. Next, backtranslation shows to have high impact on the user confidence but almost no real effect on the objective quality. Paraphrasing slightly increases the confidence but not at all the quality. And finally, the word-level quality estimation only decreases user confidence, from which we conclude that the current form is not ready for user-facing applications. One of the caveats of our work is that the vast majority of the produced translations had very high self-reported confidence and very high objective quality. This is a good thing in terms of MT progress, but it makes the results harder to interpret. This could be resolved by focusing on more low-resource language directions other than Czech English and Estonian English, or by asking the users to translate more complex queries. Lastly, let's look at 3 examples of the intermediate and final inputs in the translations to Czech. The intermediate input is a viable rephrasing of the original query that user at some point considered but abandoned at the end. In the top 2, the rephrasing helped to improve the translation quality. First, by adding a word language to prevent translating English as a Czech word for Englishman. And secondly, by substituting a preposition. Conversely, the replacement of the verb has expired by a phrase out of date led to a drop in translation quality. This is due to a grammatical error and use of the Czech expression meaning got obsolete, which indeed sounds old-fashioned in this context. To conclude, in this work we defined the issue of inbound and outbound translation. And in an experiment, we saw that NT system speed is more important in user confidence than its objective quality. And finally, we focus on backtranslation, which is a common practice for many people and me as well, when using publicly available NT systems. We saw that providing this feedback helps only in their confidence, but not at all the overall translation quality. Thank you everyone for your attention, and I look forward to the follow-up discussion.